Alright everybody, welcome back to the channel, and our improvement of the day is continuing to learn about TE coolers. Now if you missed the first video on thermoelectric cooling, I'll link that down below. So we're going to continue in this video by doing a project. We're going to build a miniature AC unit. Here we go. Now the project idea is very simple. Hook a couple TE coolers together, slap them on a big heat sink, put that heat sink in ice water to help dissipate the heat, have some fans in there to help circulate the cool air, put that in an enclosure, call it a day. So first I got to designing. Okay, so here's my design. I use SolidWorks and I'm a middling CAD designer, but I can do simple things like this. So here we have the enclosure itself. These are holes in the space for a large fan at the input. This is a hole for the power input. This ledge is where the heat sink sits, and the water of course here is at the bottom. And then that's about it. And of course, I also designed a top, which you can see right here. So the top goes on there, and that's all it is. Pretty simple. Now I have a 3D printer that I'm going to use to print this box that I just designed. So here is the box in a program called Cura. I go ahead and I slice it. Slice it means that I'm sending it to the printer and it's going to create these layers that build up on each other. So you can see how it builds from the bottom to the top. These light blue parts here are supports. You need supports when you have a big aperture like this. So this is what it's going to look like when it prints from the bottom to the top. And you see that it's going to take quite a long time. This is 5 days, 14 hours, 45 minutes. All right, here we go. Okay, so here you can see the box being printed on my printer. This is an Ender 5 Pro. I bought a few years ago, works pretty good. And here you can see at the very end, sitting on my table. I think it came out pretty good. So at this point, we're feeling pretty good about ourselves. Design went good. Print went good, even though it took forever. So the first test is this thing waterproof? Turns out, no it is not. Immediate fail. So the issue is that I used a material called PLA+, which turns out to be not waterproof. Didn't know that. So that's why we do these things. That's why we do these projects. If you're interested in how I do my 3D printing, the differences between materials, I can do another video on that later. But for now, we got to fix this. So time to get our Flex Seal out. Boom, dramatic entry. So Flex Seal, as seen on TV, this stuff really works. It's great for waterproofing anything that you need. Basically, it's sort of liquid plastic in a can, but it really does work. So I'm gonna go ahead and start hosing this thing down. Got to make sure, a little test spray there. Make sure that you get every nook and cranny, of course, but the spray is real good at covering every inch. It is a little bit stringy. Got to make sure you get every side. Let's be thorough here. Okay, I'm not going to cut any corners. And then when you're done, why don't we go ahead and leave it out in the sun for a while? That couldn't hurt, right? Wrong. Okay, you thought that you were just going to leave this thing out in the sun. Take a look at this. It's all deformed, melted, pathetic looking. All right, this is not satisfactory. The problem here is that I left it in the hot sun for maybe, I don't know, 5 or 6 hours, and it turns out that PLA Plus has a pretty low melting point. Didn't know that. Mistake number 2. So I had to start over with the printing. This time I used a new material called PETG, which has a higher melting point. Let's see if this is any better.
6
days
later.
Actually, that was a lie. It was more like 30 days. This PETG material is a real pain to print with, but I finally got it working. Here's the end result. I think it turned out pretty good. All right, this video is getting a little bit long, so I'm gonna have a part 2 to this video where I actually construct the box and we'll see how it goes. See you then.